Secure that line, sailor!
Aye, sir. Moving now.
Note the condition of these mats and the water rations here.
Yes, Colonel. I am making a note of the grime levels now.
Radar contact bearing 090, range 40 miles. All hands, man your battle stations.
Aye, aye, sir. Contact confirmed.
New sweep bearing 110, fast mover.
Roger that. Marking position, Baker.
The Pacific Ocean, summer of 1944. The air hangs heavy with salt and heat, pressing down on steel decks that have known months of sun and war. Somewhere west of the Marianas, an American warship rides at anchor. Its gray hull bears the marks of long service, but inside, something feels wrong to the men who have just stepped aboard. Japanese naval officers, captured or observing through intelligence channels, expected the familiar. Narrow passageways, sweltering compartments, men stripped to the waist, drenched in sweat, enduring heat as a matter of duty. That was how war at sea was fought in the tropics. Instead, they encountered moving air, cool air, ventilation ducts hum softly above command spaces. Air flows through radar rooms packed with glowing screens. In the heart of the ship, deep below the waterline, temperature and humidity are controlled with mechanical precision. Sailors work fully clothed, alert, unshaken by the tropical sun burning just beyond the steel bulkheads. For the Japanese officers who learned of this, the shock was not comfort itself. It was what comfort implied. It suggested preparation for a long war. A war measured not in weeks or decisive battles, but in years of sustained pressure. And in that quiet realization, something fundamental began to shift. Because to understand why air conditioning mattered, one must first understand how differently both sides believed this war would be fought. By the time Japanese planners looked east across the Pacific in 1941, they believed they understood the nature of the war they were about to fight. The Imperial Japanese Navy had been shaped by a single overriding assumption. The conflict would be short, decisive, settled by a climactic confrontation between battle fleets somewhere in the Western Pacific. This belief, rooted in the legacy of Tsushima in 1905, shaped everything that followed. Ship design, crew training, logistics, even daily life aboard a vessel. Endurance was respected. Comfort was not. Japanese warships were built lean and tightly packed. Space was sacrificed for speed, armament, and fuel. Ventilation was minimal. Insulation was rare. Below decks, heat collected and lingered, especially in the tropics. In engine rooms, temperatures routinely climbed above 45 degrees Celsius. Crews slept shoulder to shoulder, rotating through hammocks or thin mats. Fresh water was rationed. Bathing was infrequent. Sweat, oil, and salt became part of the uniform. These conditions were not considered a flaw. They were a test. Imperial doctrine emphasized spiritual strength over physical ease. Hardship was believed to sharpen discipline and suppress individual weakness. A sailor who endured heat and fatigue without complaint was seen as closer to the ideal warrior. Officers shared much of this burden. While they enjoyed marginally better quarters, they lived within the same oppressive climate as their men. In the early campaigns of 1941 and 1942, this philosophy appeared justified. Japanese forces advanced rapidly across Southeast Asia and the Pacific. British, Dutch, and American positions fell in quick succession. From the Japanese perspective, the enemy seemed unprepared, fragmented, and slow to respond. The war appeared to be unfolding exactly as predicted. But beneath the surface, warning signs were already present. As Japanese ships pushed farther south toward the equator, heat became an invisible enemy. Prolonged operations strained crews. Fatigue reduced alertness. Maintenance suffered. Electronics, already less developed than their American counterparts, were particularly vulnerable to humidity. Radar, still limited within the Imperial Navy, was often unreliable in tropical conditions. Ammunition degraded faster. Food spoiled quickly. Still, these problems were tolerated. They were expected to be temporary. Japanese logistics planning reflected this mindset. Supply chains were thin. Repair infrastructure was limited. Ships were expected to fight hard, withdraw briefly, and return to battle. There was little expectation of continuous, high-tempo operations lasting months on end. The idea of rotating crews for rest or refit was not central to Japanese naval thinking. The human cost of this approach became more visible as the war progressed. During the Guadalcanal campaign in late 1942, Japanese sailors and soldiers alike suffered from exhaustion, malnutrition, and disease. Ships ran at maximum effort under constant threat. Crewmen remained at action stations for extended periods in stifling compartments. Heat stroke and dehydration were common, though rarely recorded in official reports. To acknowledge such weaknesses risked undermining morale and doctrine. Meanwhile, Japanese intelligence officers began gathering fragments of an unsettling picture. Captured documents, prisoner interrogations, observations from submarines and aircraft. These sources hinted at something fundamentally different about the American fleet. U.S. ships appeared to remain on station longer. Their crews seemed less visibly exhausted. Radar operators worked for extended shifts without collapse. Command centers functioned continuously, day and night. At first, this was attributed to exaggeration or enemy propaganda. But as encounters multiplied in 1942 and early 1943, the pattern held. American ships were not simply fighting battles. They were sustaining pressure, returning quickly after damage, maintaining operational tempo in a way the Imperial Navy found increasingly difficult to match. The difference was not yet fully understood, but it was becoming impossible to ignore. Because behind American endurance lay a philosophy of war that Japan had not anticipated. And to grasp that contrast, one must look across the ocean into the shipyards and design bureaus of the United States Navy. Across the Pacific, the United States Navy entered the war carrying a very different memory of naval conflict. American planners did not expect a short war. Their doctrine, shaped by World War I and decades of industrial planning, assumed that any major conflict between great powers would be long, grinding, and logistically demanding. Victory would not come from a single decisive clash, but from sustained operations across vast distances. This belief was embedded into steel long before Pearl Harbor. U.S. warships were designed with habitability as a core requirement, not an afterthought. The Bureau of Ships, responsible for naval engineering, treated crew endurance as a combat multiplier. Fatigued sailors made mistakes. Overheated operators misread instruments. Poorly rested crews reacted slower under fire. These are not moral failings. They were engineering problems. The Pacific climate reinforced this logic. From the Central Pacific to the South China Sea, heat and humidity were constants. Electronics, ammunition, and human bodies all degraded under prolonged exposure. American naval engineers understood that if ships were to fight continuously in these conditions, the environment inside the hull had to be controlled. Air conditioning was the solution. By the late 1930s, U.S. naval architects were already incorporating mechanical ventilation and cooling into new designs. Early systems were bulky and energy-intensive, but they served critical functions. Combat information centers, radar rooms, plotting spaces, and communications hubs required stable temperatures to function properly. Sensitive vacuum tubes and electrical components failed rapidly when overheated. Cooling was not a luxury. It was a necessity. When war came, this philosophy expanded rapidly. Fleet carriers like the Essex class were built with extensive climate control. Not every compartment was cooled, but critical spaces were. Command areas, medical bays, magazines, and radar rooms operated in controlled environments. Even crew living spaces benefited from improved ventilation compared to earlier generations of ships. Below decks, air circulated continuously, pushing heat and moisture out through ducts and vents. The effect on operations was profound. American crews could remain at battle stations longer without collapse. Radar operators worked through the night, tracking contacts with steady concentration. Damage control teams functioned in conditions that, while still harsh, were survivable. Medical staff treated heat exhaustion less frequently than their counterparts in other navies. Just as importantly, these systems reflected the scale of American industry. The United States could afford the weight, space, and power requirements of air conditioning. Its ships were larger. Its generators were stronger. Its fuel supply was abundant. Where Japanese designers shaved tons to maximize speed and armament, Americans accepted heavier hulls in exchange for endurance and sustainability. This was not indulgence. It was foresight. As the war intensified in 1942 and 1943, American shipyards refined these systems further. Lessons from early battles were fed back into design improvements. Ventilation was strengthened. Cooling systems were made more reliable. Repair ships and tenders were equipped to maintain them in forward areas. Floating dry docks carried spare parts and trained technicians. The result was a fleet capable of fighting continuously across thousands of miles of ocean. Japanese observers struggled to reconcile this reality with their own experience. To them, war at sea had always meant discomfort as a given. That an enemy could engineer such conditions out of existence seemed unnatural, even suspect. Yet the implications were impossible to dismiss, because comfort did not merely preserve bodies. It preserved decision-making. It preserved reaction time. And over months of combat, those small advantages accumulated into something far larger. As these two philosophies collided in battle, the contrast became clearer through individual experiences, technological realities, and strategic consequences, each revealing a different facet of the same underlying truth. The first contrast revealed itself not in blueprints or reports, but in the bodies of the men who fought inside these ships. For Japanese sailors, heat was constant and inescapable. Watches stretched on in airless compartments where sweat soaked clothing within minutes. During prolonged alerts, men remained at action stations for hours, sometimes days, with little relief. Concentration dulled. Tempers shortened. Small errors crept in unnoticed. This was accepted as the price of war. American crews experienced something different. On U.S. carriers and cruisers, radar operators worked in cooled, enclosed spaces. Plotting rooms remained dry and legible. Communications teams functioned without heat-induced fatigue. Even partial cooling made a measurable difference. Sailors emerged from long shifts tired but functional. They could think. They could react. This human difference fed directly into combat performance. In night actions, American radar teams maintained sharp contact, tracking long after darkness fell. During extended operations, U.S. task forces sustained higher sortie rates. Pilots returned to ships where maintenance crews, not half delirious from heat, prepared aircraft with methodical efficiency. Over weeks and months, this consistency mattered more than individual heroics. The second angle was technological, and it was inseparable from air conditioning. Radar was the nervous system of the modern fleet. But early radar sets were fragile. Vacuum tubes overheated easily. Moisture caused corrosion and signal distortion. Japanese radar systems, already fewer in number and less advanced, suffered badly in tropical conditions. Operators worked in stifling rooms, fighting both enemy contact and environmental failure. American radar rooms, by contrast, were cooled and sealed. Temperature stability extended equipment life. Readings were clearer. Breakdowns were fewer. This advantage compounded itself during major engagements like the Philippine Sea, where radar-directed fighters intercepted Japanese aircraft long before visual contact. To Japanese intelligence officers analyzing these battles, the pattern was troubling. Reports described American ships that remained operational longer, even after damage. Crews appeared disciplined, but not exhausted. Captured sailors spoke casually of cooled spaces, of sleeping in relative comfort, even near the equator. For officers raised on the belief that hardship forged superiority, this was disorienting. Some dismissed it as softness. Others recognized it as something more dangerous. Because the third angle was cultural. Japanese military culture equated endurance with virtue. American engineering appeared to remove endurance from the equation entirely. The implication was unsettling. If suffering was no longer required to function, then the enemy could sustain operations without moral or physical collapse. That realization lingered, and as the war ground on, these impressions deepened, revealing consequences that reached beyond individual ships and into the strategic heart of the conflict. The fourth angle emerged at the level where individual endurance became strategy. The United States Navy did not measure success solely by battles won, but by days maintained on station, weeks of uninterrupted operations, months without returning to a major port. Air conditioning, ventilation, and habitability systems made this possible. Crews could be rotated internally rather than evacuated. Ships could remain forward deployed with fewer pauses for rest and recovery. For Japanese planners, this endurance was deeply unsettling. Imperial doctrine had assumed that sustained pressure would exhaust any opponent operating so far from home. Instead, American task forces seemed to grow stronger over time. Damage was repaired at sea. Crews recovered without leaving the combat zone. Command staffs functioned continuously, supported by cooled operations centers where decisions were made with clarity rather than desperation. This led to a fifth angle, morale. Japanese officers reviewing post-engagement intelligence noted an absence of visible strain among American sailors. Not a lack of fear, but a lack of physical collapse. Comfort did not make them careless. It made them consistent. In contrast, Japanese crews, living under increasingly severe conditions as fuel and supplies dwindled, suffered compounding fatigue. Heat aggravated malnutrition. Malnutrition weakened resistance to disease. Disease reduced combat effectiveness. By late 1943, this disparity could no longer be ignored. Some Japanese officers began questioning whether hardship alone truly produced superior warriors. Others resented what they perceived as American indulgence, viewing it as evidence of industrial excess rather than strategic foresight. But resentment did not change reality. Each month, American operational tempo increased while Japan's declined. The sixth angle was psychological, and it cut deepest. Air conditioning became a symbol, not of luxury, but of inevitability. It represented an enemy who expected to be present tomorrow, and the day after, and the month after that. An enemy whose war planning extended beyond sacrifice toward sustainability. For Japanese intelligence analysts, this realization was chilling. Because if the enemy could engineer away exhaustion, then time itself favored them. Every additional week of fighting eroded Japanese strength, while leaving American capability largely intact. The war was no longer a test of spirit alone. It was a contest of systems. And as these systems collided in the great battles of 1943 and 1944, there came a moment when the implications of this imbalance became impossible to deny, a turning point where comfort, endurance, and industrial power revealed their full strategic weight. By mid-1943, the Pacific War had entered a new phase. The battles were no longer isolated clashes at the edges of empires. They were sustained campaigns stretching across entire ocean basins. For the Imperial Japanese Navy, this shift exposed the limits of assumptions made years earlier. And nowhere was this more apparent than in the long sequence of engagements that followed Guadalcanal. After the brutal fighting around the Solomon Islands, Japanese forces withdrew, battered but still dangerous. Yet the nature of the withdrawal itself revealed something unsettling. American ships remained on station. Carriers returned quickly after repairs. Task forces rotated through combat zones with barely a pause. What had once seemed extraordinary now appeared routine. Japanese intelligence officers began compiling reports not just on enemy numbers, but on enemy endurance. One report, based on post-battle observations and prisoner interrogations, noted that American radar operators appeared unusually alert during extended night actions. Another described command spaces that functioned continuously for days without visible degradation in performance. The explanation was no longer attributed to morale alone. Environmental control was now explicitly mentioned. The realization sharpened during the Battle of the Philippine Sea in June 1944. As Japanese carrier aircraft launched into the humid air, their crews already exhausted by heat and limited rest, American fighters rose to meet them. Radar-directed interceptions began hours before visual contact. In cooled combat information centers, American officers tracked incoming formations with precision. Decisions were made calmly, methodically, as wave after wave of Japanese aircraft was detected and destroyed. For Japanese survivors and analysts, the imbalance was unmistakable. Their pilots had flown from ships where maintenance crews worked in sweltering hangars, struggling against fatigue and equipment failures. American pilots returned to carriers where aircraft were refueled and rearmed by teams operating under comparatively stable conditions. The difference was not dramatic in any single moment. It was cumulative, relentless. The turning point was not simply the loss of aircraft or ships. It was the loss of illusion. By 1944, Japanese officers increasingly understood that the United States was not merely winning battles. It was mastering time. The American fleet could fight today and be ready again tomorrow. Japan could not. Capture documents and post-action reports reflected a growing sense of inevitability. References to American material superiority became more frequent. So did comments on the difficulty of matching operational tempo under tropical conditions. Air conditioning, once dismissed as an indulgence, was now recognized as part of a broader system that Japan lacked the resources to replicate. This recognition did not end the war, but it changed how Japanese leaders understood it. Because from this point forward, every major engagement carried the weight of a deeper truth, that the gap between the two fleets was no longer tactical. It was structural, and that gap would only widen. Once the realization set in, the Imperial Japanese Navy faced a problem with no practical solution. By late 1944, Japanese shipyards were struggling simply to replace losses. Steel was scarce. Fuel was scarcer. Skilled labor had been siphoned into other war industries or lost to bombing. Under these conditions, the idea of retrofitting ships with advanced ventilation or cooling systems was unrealistic. Even basic repairs were delayed. Electrical power was rationed. Generators ran at minimal output to conserve fuel. Attempts were made to adapt. Ventilation was improved where possible. Crew rotations were adjusted in theory, though rarely in practice. Officers issued guidance on reducing fatigue through discipline and routine. But none of this addressed the core problem. The Japanese fleet lacked the industrial depth to engineer comfort into its vessels. More importantly, it lacked the doctrinal framework to prioritize it. Cultural resistance remained strong. For many senior officers, acknowledging the importance of comfort felt dangerously close to admitting ideological failure. The belief that spiritual strength could overcome material disadvantage was deeply ingrained. Even as evidence mounted, change came slowly, if at all. The war did not allow time for institutional transformation. Meanwhile, the American system continued to evolve. By 1945, U.S. task forces operated with near-continuous efficiency. Repair ships, floating dry docks, and logistics vessels followed the fleet, maintaining not only hulls and engines, but life support systems. Air conditioning units were serviced, upgraded, and standardized. New ships arrived from shipyards already incorporating lessons learned from years of combat. Japanese officers observing from afar understood the implications. This was no longer a contest that could be reversed through courage or sacrifice. The structural gap between the two fleets had become unbridgeable. American ships were designed to keep fighting. Japanese ships were designed to endure until they could not. The final battles of the war reflected this reality. At Leyte Gulf, Japanese forces committed what remained of their fleet in a desperate attempt to alter the course of the war. The outcome was catastrophic. Ships were lost faster than they could be replaced. Crews fought bravely under punishing conditions, but exhaustion and logistical collapse undermined effectiveness at every level. After Leyte, the Imperial Japanese Navy ceased to exist as a coherent fighting force. In the aftermath, Japanese officers began to speak more openly about the causes of defeat: industrial capacity, fuel shortages, air superiority, and increasingly, the human limits imposed by environment and endurance. Air conditioning was no longer a curiosity. It was a symbol of a war Japan had not prepared to fight, a war measured not just in battles, but in the ability to sustain human performance under relentless pressure. And as the fighting drew to a close, the consequences of that realization would become fully apparent. When the guns finally fell silent, the condition of the Imperial Japanese Navy told a story that statistics alone could not. Surviving ships were hollowed out, machinery worn beyond safe limits, crews emaciated, exhausted, and often ill. In the final months of the war, many Japanese vessels operated with minimal ventilation and almost no fuel. Electrical systems were shut down whenever possible to conserve power, plunging interior spaces into suffocating darkness and heat. Sailors endured temperatures that pushed human tolerance to its edge. American intelligence officers who boarded captured ships after Japan's surrender were struck by what they found below decks. Compartments were cramped and airless. Paint blistered from heat and humidity. Equipment showed signs of long-term environmental damage. In medical reports, heat exhaustion, chronic dehydration, and tropical infections appeared repeatedly. These were not the wounds of battle, but of sustained environmental strain. Post-war interrogations with Japanese naval officers confirmed what battlefield observation had already suggested. Many acknowledged that prolonged operations in tropical waters had severely degraded combat effectiveness. Radar operators struggled to remain alert. Engine crews worked in near unbearable conditions. Maintenance backlogs grew as exhausted sailors fell ill or collapsed. One former officer noted that even when ships remained intact, the men inside them were already worn down. By contrast, assessments of American ships painted a different picture. U.S. Navy medical and engineering reports showed lower rates of heat-related illness relative to time at sea. Crews remained functional over extended deployments. Habitability systems, including air conditioning, were credited with preserving alertness in command spaces and reducing long-term fatigue. These findings were not framed as comfort studies, but as operational analysis. The difference was especially visible in late war operations. While Japanese ships increasingly remained in port due to crew exhaustion and fuel shortages, American task forces maintained near-continuous presence across the Western Pacific. Even after intense engagements, U.S. ships returned to readiness with speed that astonished former adversaries. The war had become less about surviving individual battles and more about sustaining systems over time. For Japanese officers reflecting on defeat, this contrast was difficult to ignore. They had fought with discipline and courage, but they had done so inside ships that demanded constant physical sacrifice simply to function. In the end, that sacrifice proved unsustainable. And as post-war analysis deepened, Japanese leaders began to articulate lessons that went beyond weapons or tactics, pointing toward a more fundamental understanding of modern naval warfare. In the years immediately following the war, Japanese naval officers were encouraged to speak with unusual candor. Under Allied supervision, Detailed debriefings were conducted to understand how the Imperial Japanese Navy had fought and how it had failed. These sessions produced a body of analysis that extended beyond strategy and into the lived experience of war at sea. Among the topics that surfaced repeatedly was endurance. Former officers described a fleet designed for intensity, not duration. Ships optimized for speed and striking power, but unforgiving to the men inside them. Many acknowledged that this design philosophy, combined with limited industrial capacity, left Japan ill-prepared for a prolonged conflict in the tropics. American naval analysts listening to these accounts drew their own conclusions. They noted that habitability had functioned as an invisible force multiplier. Air conditioning, ventilation, freshwater systems, and medical facilities allowed American crews to maintain operational effectiveness over time. These systems did not win battles directly. They enabled the conditions under which battles could be won consistently. This lesson was institutionalized. Post-war U.S. naval design standards placed even greater emphasis on environmental control. Submarines, surface combatants, and carriers were built with comprehensive climate systems as a baseline requirement. The logic was clear. Modern naval warfare depended on electronics, sustained alertness, and human performance under stress. Controlling the internal environment was essential to all three. Japanese post-war maritime planning absorbed similar lessons. In the reconstruction of Japan's naval and maritime forces, habitability became a recognized component of operational design. Comfort was no longer viewed as indulgence, but as protection against human limitation. The war had demonstrated that ideology could not override physiology. The shocked Japanese officers felt upon learning that American ships were air-conditioned lingered, not because of the technology itself, but because of what it revealed. It exposed a mismatch in assumptions about how wars are fought. One side prepared for a decisive moment. The other prepared for endless strain. When those approaches collided, the outcome was determined not in a single battle, but over months and years of sustained pressure. As the last reports were written and the archives closed, a quieter question remained. What did this realization mean for the future of warfare and for the humans asked to fight it? In the stillness after the guns, the story of air conditioning aboard American ships seems almost poetic, small, technical, almost mundane. Yet it carried consequences that shaped the Pacific War in profound ways. War is often measured in battles, tonnage sunk, and territories gained. But it is also measured in endurance, in the ability of human beings to continue functioning, thinking, and deciding under relentless pressure. In that measure, the United States and Japan fought a quiet, invisible battle long before shells fell. Air conditioning was never a luxury. It was a tool of war, a technological acknowledgement that men cannot fight effectively when their bodies fail. In cooled compartments, radar operators tracked planes, engineers repaired engines, and commanders made decisions with clarity that heat-stressed minds could not provide. Across months of sustained operations, these small advantages multiplied into decisive operational strength. For Japanese officers, the shock of encountering this reality was profound. It revealed a war they had not fully understood, not a contest of courage alone, but of industrial foresight, human endurance, and the careful orchestration of environment. Their lessons, learned too late, underscored a truth that resonates beyond history. That warfare is as much about sustaining life and thought as it is about destroying material. And so, in the heat of the Pacific, in the silent hum of a ventilated CIC, we find a quiet illustration of how technology and humanity intersect in war. A reminder that sometimes victory is found not in might, but in the simple act of keeping men alive, alert, and capable. The ships would sail, the battles would rage, and the oceans would carry forward the echoes of lessons learned. In air, in steel, and in the endurance of those who endured. In the stillness after the guns, the story of air conditioning aboard American ships seems almost poetic, small, technical, almost mundane. Yet it carried consequences that shaped the Pacific War in profound ways. War is often measured in battles, tonnage sunk, and territories gained. But it is also measured in endurance, in the ability of human beings to continue functioning, thinking, and deciding under relentless pressure. In that measure, the United States and Japan fought a quiet, invisible battle long before shells fell. Air conditioning was never a luxury. It was a tool of war, a technological acknowledgement that men cannot fight effectively when their bodies fail. In cooled compartments, radar operators tracked planes, engineers repaired engines, and commanders made decisions with clarity that heat-stressed minds could not provide. Across months of sustained operations, these small advantages multiplied into decisive operational strength. For Japanese officers, the shock of encountering this reality was profound. It revealed a war they had not fully understood, not a contest of courage alone, but of industrial foresight, human endurance, and the careful orchestration of environment. Their lessons, learned too late, underscored a truth that resonates beyond history. That warfare is as much about sustaining life and thought as it is about destroying material. And so, in the heat of the Pacific, in the silent hum of a ventilated CIC, we find a quiet illustration of how technology and humanity intersect in war. A reminder that sometimes victory is found not in might, but in the simple act of keeping men alive, alert, and capable. The ships would sail, the battles would rage, and the oceans would carry forward the echoes of lessons learned. In air, in steel, and in the endurance of those who endured.